For Bridgett, Harvey.
Hello. Hi, everyone. Okay, like I said, my name is Bridgett. I'm here at the Science Center of Iowa to talk a little bit about ice, but it's not necessarily the kind of ice you would expect. The type of ice we're going to talk about today is called dry ice, and I'm going to bring some up here, show you all. Okay, so dry ice is a little different than regular ice in that it literally has a liquid stage. It goes straight from a solid to a gas. As you can probably maybe see a little bit if you're kind of close, there's all kinds of gas coming off of this solid dry ice here. There's no liquid whatsoever, which is much different than like an ice cube or a popsicle or anything else made out of water, any other ice made out of water. So the process that something goes through when it skips the liquid stage and goes straight from a solid to a gas is called sublimation. Can we all say that together? Sublimation. And it kind of helps if you wiggle your fingers. Okay, so dry ice is actually about 4.5 times colder than the ice you see out there on the rink today. The ice on the rink is between 24 and 26 degrees Fahrenheit, so it's still above zero, but it's below freezing. This ice is 109 degrees below zero Fahrenheit, or about the temperature of the coldest day of the year on Antarctica. And since it's so cold, we can do a lot of really cool experiments with it. So I'm just going to set this piece aside and take my jar of dry ice here, pour it into a container of water, and put on my safety goggles, and check out this really cool effect we have here. It kind of looks like fog or a cloud. And what's happening here is that dry ice is releasing that gas, picking up all kinds of water vapor, and making it look like fog or a cloud. Now, we can do some stuff that's even more cool. I can take this soggy paper towel that's been soaking in some Dawn dish soap, drag it over the lip of the jar, and it's a crystal ball. Okay, let's try it again. Here we go. We've got a crystal ball. One more time. I'm going to try to predict the future here. I predict that you all are going to have a wonderful rest of the day at the game here. Not predicting any outcome. We'll do it one more time. Here we go. So watch as that bubble fills up with gas, and then the gas actually pulls the bubble over the edge of the lip of the jar, causing that bubble to break. Now, this container's a little silly. It's got a tube coming out of it and a little funnel on the end of the tube. We can actually put a lid on the jar and then funnel that gas out from the tube, dip that funnel into some soap, and make little tiny ghost bubbles. Check that out. Do some more here. Now watch as these bubbles release themselves from the funnel. Are they pretty similar to the bubbles that you would blow with your breath with a bubble wand? No, because which direction are they going? Show me with your hands. Down, yeah, they're going down because they're very, very dense. The gas inside is very dense and very cold. And cold things like to stay down, okay? So, this experiment we saw here all dealt with some physical changes. We still had dry ice and we still had water. We just watched it change physically. Next, we're going to check out a chemical change. We're actually going to change some things here chemically. So, I have two graduated cylinders. This one is just filled with regular tap water, and I'm going to add a chemical called an indicator solution. And it's going to change the color of our water here to like a reddish color. And what an indicator solution tells us is it tells us a little bit about the pH of the solution. Raise your hand if you've ever heard of pH, or an acid or a base. Very good. Raise your hand if you've ever gone swimming or had a fish tank. Awesome. If you've ever been swimming and the lifeguard blows It's starting to change. It went from like a dark red to what color? A pinkish color, yeah. And what that's telling us is something has actually changed chemically inside of the solution. Now, dry ice, do we think that's just regular, really, really, really cold water? No, it's made out of something totally different. Everybody take a deep breath in. And hold it for as long as you can. Just kidding, let it out. What's the gas called that comes out of your lungs? Very good, carbon dioxide gas. Well, dry ice is made out of carbon dioxide gas. It's the solid form of the gas we exhale. When you put carbon dioxide in water, it makes something called carbonic acid. Raise your hand if you've ever had carbonic acid. Nobody? Not really? Raise your hand if you've had a pop or a soda today. Oh yeah, then you've had carbonic acid. That's all carbonation is carbon dioxide gas suspended in a liquid. Pretty cool. So since dry ice is so cold, you actually have to be an adult to purchase it from the store. And if you want to try dry ice experiments at home, make sure you ask a responsible adult or a parent to work with dry ice with you, and you can try these experiments at home. Now, an experiment that's a little bit more safe that you usually don't have to ask your parents to do is to test if hot water will freeze faster than cold water. Okay? So you can have two separate ice trays, fill one with hot water, fill one with cold water, and test to see which one will freeze faster. Now, what temperature do Zambonis use on the ice? Hot water or cold water? You guys know? Some believe that it could be hot water to help the ice freeze faster.